Welcome back, everyone. Now, we've already talked about all the different types of access lists that we're going to create. In this particular lab right here that we're going to use, we're going to create a standard access list. So you already know what they do. You know the disadvantages. You know what we need to apply them. So let's go ahead inside the lab and create our standard access list. Standard access list lab. Well, we've talked about the standard, extended, name, remarks, all that stuff. Well, we're going to go ahead and do a standard access list. As I said earlier, a standard access list is very limiting because you can only use source addresses. Source addresses. You can't use source and destination or protocol or port numbers like an extended access list. So you're very limited as to what you're going to do. So what we're going to do now, we're first going to check for connectivity. And let's just pick on PC2 now, because we should have everything configured. We should have connectivity across our network. Let's go ahead and ping 192.168.100.1, and we can. And let's ping 101.1, and we can. So we do have connectivity across our network. So what we're going to do is we're going to create an access list that's going to deny the 192.168.100.0 network, that entire network, to access the 192.168.102.1 host. Well, we can't do that. It's the entire network. I'm sorry. It's the 192.168. So we cannot access the whole 102 network. We can't do that. But we can't tell it that. All we can tell it, hey, we're denying the 100. That's all we can say. So that's why a standard access list is placed nearest the destination. So in this case, since we're denying this guy from this, we're going to go ahead and create and apply the access list to this particular router. So let's do so. All right, let's maximize the router. Let's do a config T. And we're going to do access list within the range of an access list. That's 1. Deny the 192.168.100.0, 0.00255. So we're denying that entire network. Now remember, there's an implicit deny at the end of every access list. So if I don't put a permit statement here, it's going to deny everybody else too. So I got to come back and say, okay, access list 1, permit any. As we know already, access lists are read line per line from top to bottom. So if anybody from the 100 network comes in, is going to read the first line, says, oh, you're denied. But if somebody from the 100.2 comes in, it doesn't match the 100, so it goes to the next line, and the next line says permit any, so it will permit that one. Now I say come in, so because this is nearest the destination, so it's got to be nearest the actual PC from the router, obviously. So we're going to go into interface F0/0, and we got to apply it. Just because you create an access list on the router doesn't mean it's doing anything. You have to now apply it. So we're going to apply the access list. IP access -group. Which group? Group 1. And which direction? Well, it's already in the router. It's trying to come out of the router. So it's going to be out. UWR. Now, how can you look to see it? You do show access list. And that's the only access list that exists on the router. How can you see which interface, or not which interface, which direction is going to? Okay, we're going to do show IP interface F0/0. Enter. And you can see that the outgoing access list 1 is set. So this is a command if you want to see which direction that you will have to do. Show IP interface and then the interface that you applied it at. All right. So let's go ahead and test it now. Let's test it. Let's first ping from PC1, which is the 101.network. We should be allowed to ping. Ping 192.168.102.1. And we can ping without an issue. Okay, lovely. Let's go to the PC0. Okay, see we've done some stuff here before. So let's ping 192.168.102.1. Destination host unreachable. So we're being denied by that access list from accessing that particular network. So, because we're trying to get out of the router. You can see I can ping the fast Ethernet interface because I'm just pinging that interface. But as soon as I try to come out of the router, it stops me because access lists work once you go through the router. So I went through that interface, I hit those lines on that access list, and the first one read it. Hey, if you're from the 100 network, you're denied. I'm sorry, go back home. That's what a standard access list does. All right, so I'll see you outside the lab. Welcome back. That wasn't so difficult. We went ahead. We wanted to block the 100 network from accessing or for that particular host from accessing this network, right? And we had to then, that means that we had to come all the way over here and create the access list here and then apply it to that interface. In which direction? Out, right? Because it's already in the router. Now it's trying to get out of the router. And you saw that it worked, that it did work. But the problem with that is what we talked about previously, that you have to go up to your router. It starts processing it, look at its routing table, send it to the next router, he's got to process it, send it to the next router, he's got to process it. And then finally, once it hits the interface, boom, you're denied. It's like somebody inviting you to not inviting you to a party, but you know that there's a party over there, and you just drive all the way 50 miles away, all right? And then you get to the door, you knock on the door, and you're trying to get into the house, and they say, whoa, you weren't invited, leave. So you wasted gas, time, the possibility of crashing, and then you're just getting upset at the fact that they didn't want you there. So the fact is that you're wasting bandwidth, processor usage, and all that just to get denied. That is why using standard access lists for certain occasions, for certain things, it's not beneficial. This is where extended access lists really come into play, and they are beneficial. All right, with that said, I'll see you in the next one.